Figure below shows three states A, B, and C of an ideal gas with a fixed mass. Rank the volumes of the gas at each state. Take note that this graph is a P versus T graph, where the P is the pressure, T is the temperature in Kelvin. So it is not the PV graph, P versus V. V is the volumes of the gas. That means we cannot read from the graph directly what is the volumes of the gas. But we know that ideal gas obeys the equation of state, which is a PV equal to nRT. Now, if we change the P as a subject to get the P equal to nR over V times T, then if we compare with the Y equal to mx plus C, then we can know that if we draw a line that passes through the origins of this P versus T graph, then the gradients of the line will be equal to the nR over V. So that means the gradients of the graph for the line that passing through the origin, its gradient will give us the informations about the V. Now, if we draw the line that pass through the origin, we find that this line will pass through the state A and the state C, and this line will pass through the B. And by comparing the gradients of these two lines, then we can know the relationship of the volumes of the gas among these three states. To be more specific, now we know that the gradients of the line that connect the origins to the A is the MA, is the same as the gradients of the line that connect the origin and the C. So this is the MC. These two values are the same because in fact they are the same line, the gradient for the same line. And the line that connect the origin and the B will give the gradient MB, which is less than or smaller or less steeper than the line that passing through the A and C. That's why we have this MA equal to MC, which is greater than the MB. Note that this M is not referred to the mass of the gas, it is referred to the gradients of the line. Since we know from the comparisons between these expressions and the equation of line, the gradients M is bigger if the V is smaller. And when the M is smaller, that means the V is bigger. So that means from this relationship of the gradients, then we can know that the volumes of the gas at the state A must be the same as the volumes of the gas at the state C. And these two volumes should be smaller than the volumes at the state B. So this is the rank of the volumes of the gas at the state A, B, and C.